path1 90.1.1 2 3 4 5 6 7. I'll advertise them into EIGRP 10. So I'll configure EIGRP 10. I'll say node assembly network 90.1.0.0. You know very well I can take wildcard mask so that EIGRP will get enabled only on these 7 loopback interfaces only, which are having an IP address from this range only, right? I have already proved all these things, so I'm not gonna to prove these things again and again. So this time you see show IP EIGRP interfaces, right? So you can see that in EIGRP process 10 we are having all these 7 loopback interfaces. In process 100 we are having these 3 interfaces. Understood? Now by default these 90s prefixes will not move into EIGRP. When we can look at the routing table of switch 4, we must not be able to get them. Get all those prefixes over here. So we are not receiving them over here just because by default prefixes cannot move from one AS to another AS. For doing that, I'll move on switch 3 and I'll say router EIGRP. One more thing that during redistribution it is really important to use route map. During redistribution it is really important to use route map. You know why? Because with the help of route map you can perform some conditional redistribution. Like for an example, if you want to redistribute some specific prefixes only, then you can call all those prefixes in an ACL, and then further you can call that ACL into route map, and then further you can redistribute EIGRP. You can redistribute any routing protocol into EIGRP with the help of that route map. So whatever will be permitted in your route map will only be able to redistribute from one routing protocol into EIGRP. So let's say that I want to redistribute from 90.1.1.0 to 90.1.5.0. First 5 prefixes only, so I'll be doing that only, right? So to achieve that, actually I'll create first of all an ACL 10 permit, and then I'll say 90.1.0.0, and then I'll say 0.0.3.245. So it will cover from 0 to 3, right? So which means that 90.1.1.0, 90.1.2.0, 90.1.3.0 will be covered in it. But still we are having 4 and 5, right? So for doing that, I'll say access list permit 10. Your access list must be same, right? Access list number must be same. You are creating another entry in the same ACL, right? So then you would say 90.1.4.0, and then you will say 0.0.1.245. Now with the help of this wildcard mask, you will see that 4 and 5 will get matched, right? So here we will require to specify 2 different statements to call only from 1 to 5, right? Then further I'll create one another route map over here. Let's say route map redistribute from EIGRP 10 to EIGRP 100, right? Even you could take 2 and then EIGRP 100. Any problem? Then I'll say permit 10. In route map also I have to specify permit 10, because in route map if you say deny, then again those prefixes which will be matching with that deny statement will not be able to get redistributed from like EIGRP AS10 into EIGRP AS100. So we have to say permit, and then I specified sequence number 10. By default it will take its sequence number as 10 itself, right? And then I'll call my ACL under this statement match IP address, right? That is ACL number 10. So whatever will be permitted in ACL 10 will be permitted in this route map itself. Along with this, as I told you before, that you can also set tag values. So as I am redistributing all these prefixes on device number 9, so I'm setting its tag value as 90. Set tag 90. Right, and then further you go to router EIGRP 100 and then say redistribute EIGRP 10. And here you are not required to specify your matric. You know why? Because you are redistributing EIGRP into EIGRP. And if you are redistributing EIGRP into EIGRP, then you will never require to specify your matrix during redistribution, because In EIGRP 10, AS10, you are using like bandwidth, the load, delay, reliability, and MTU. Similarly, you are using all these components in EIGRP AS100. Understood? So that is why here it is not mandatory or it is not required to specify your matrix during redistribution. So I'll simply say EIGRP 10 and then I'll say route map, and route map name was, I'll just copy and paste over here. This is my route map name. Redistribute from EIGRP 10 into EIGRP AS100, right? This was my route map name. So I'll be using this route map over here during redistribution. And if you redistribute anything with the help of route map, now you can look at this output that it will be redistributing only those prefixes which are permitted in this route map, and also along with that it will set tag value 90 in all redistributed prefixes. To confirm it, let's move on to switch 4, because we must be able to see all of them now on to switch 4 itself. So let's look at switch 4's routing table. You see that from 1 to 5 all of them are available in its routing table, but 6 and 7 were not redistributed, right? That is why 90.1.6.0 and 90.1.7.0 are not available in the routing table of switch 4, right? And if you want to look at the tag value, then definitely I can have that tag value as well. Like I will show you that tag value here. So I EIGRP topology 90.1.0 and then I have specified segment mask. It will show you that what is the tag value for it. So tag right, and this information is also there that originating router is having this router ID. This is the router ID of originating router, which means that this is the router ID of that router where we performed redistribution, right? So we redistributed this 90.1.0/24 prefix on that router, which is having router ID 155.1.9.9. And now you can see, or you can look at switch 3's configuration, that why it chose this 155.1.9.9, because we are having here two loopback interfaces, loopback 0 and loopback 9 in AS100, right? In AS100 here we are having two loopback interfaces, loopback 0 and loopback 9. And if you are having multiple loopback interfaces, then again it will opt that loopback which is having higher IP address. So which loopback is having higher IP address? It's loopback 9. Remember that in EIGRP, selection of router ID would be, the process of selecting router ID would remain same as OSPF and all other routing protocols. Like first of all, it will prefer that router ID which you configured manually, and second, it will look at the highest loopback interface, and if there is no loopback interface available, then it will be looking at highest. It will pick that IP address which is the highest IP address configured on among all physical interface. It will pick its router ID from the physical interfaces, and it will opt that IP address which is the highest one, right? So first of all, statically configured, then second highest loopback, and then finally highest physical interface IP address. So that's why switch 3's router ID is this. Even I can do one thing, because this is device number 9. So I can do one thing, router EIGRP 100. Remember that if you want to configure router ID in EIGRP, then your command will be EIGRP router ID, and then you can configure its router ID as 9.9.9. Means I modified its router ID manually. So we can modify router ID in EIGRP in this manner, right? Now let's move back again onto switch 4, and this time in this prefix we must be able to see 9.9.9.9. Then so this time its router ID is what? 9.9.9, which means that this prefix was redistributed onto this device. Now I wanted to show you that in T-Shoot what can they do. They can configure same router ID on switch 4 itself. Like router EIGRP 100, they can say EIGRP router ID 9.9.9. Now remember, in EIGRP classic mode, if we take an example of classic mode, then in all external prefixes it will always carry forward originator's router ID in its updates. That's why you were getting all those, all that information in its topology table. You see that originating router is this, and the AS number from where it was redistributed was AS10, and the action routing protocol was EIGRP. You understand? So all this information was kept by EIGRP updates, and all this information will be propagated throughout the network. All devices, all routers will be having this information. Now, for loop prevention mechanism, there is a loop prevention mechanism for external prefixes in EIGRP, that if EIGRP receive any external prefix, it will look at the originator ID. If its own router ID is same as the originator ID received in external prefixes, then it will simply discard all those incoming updates, incoming routes. So this time, because whenever this switch 4 will look at the originator ID and then will compare that originator ID with its own router ID. So it will find that, okay, which means that these prefixes were originated by itself, right? So this time switch 4 is not going to accept all those external prefixes, right? That is why you will not be able to receive, or you will not be able to find them into its own routing table. You can look at its routing table. You must not be able to see any one of the prefix which belongs to 90s network. Any problem? But still you can find all these prefixes, all these 90s prefixes in the routing table of switch 2. So you can look at the routing table of switch 2. Let me show you. You must be able to get them in its routing table. However, switch 2 will keep on to forward these updates towards switch 4, but switch 4 is not going to accept any one of the prefix which are containing its own router ID. So this time, because switch 4 was having router ID same as switch 3, that is why it is not possible for switch 4 to receive all those 90s prefixes. So this is really important to understand in perspective of troubleshooting. In T-shoot, they can inject this type of fault right over there, so you must be really careful about all these small faults. So let's move again back onto switch 4. Say EIGRP 100 EIGRP router ID, let's say switch 4, so router ID is 10.10.10.10, and once again you will be able to see all those 90s prefixes available in its routing table. So I hope that you have understood the uses of router ID in EIGRP. This is the only uses of router ID in EIGRP. Apart from it, there is no other use of router ID in EIGRP. But one more thing I would like to tell you, that if EIGRP does not have any router ID, if EIGRP does not have any router ID, till that EIGRP will not process, or its process will not get started. So it is mandatory for EIGRP to have router ID to get started. Right? For an example, if you have allocated only an IPv6 addresses to your device, and then after you are trying to run the process of EIGRP, because still in all routing protocols, router IDs are allocated in the format of IPv4 addresses, right? So in that case, your routing protocol will not be able to pick router ID automatically, right? So in that case, it will be mandatory for us to allocate router ID to the process of the EIGRP, right? To force EIGRP to start its process. Without having router ID, it will not be possible for EIGRP to start its process.
So why they made this rule, like when you will get any update, then you have to match or you have to check the router ID? Why?
Just because of routing loop prevention. As I told you before, I told you, like, this router ID will be in use in EIGRP for routing loop prevention. Like for an example, let's say these prefixes were redistributed by switch 3, and these prefixes are coming back onto switch 3 now from somewhere else, right? So if switch 3 starts receiving all those prefixes, right, from let's say for an example, just try to understand it now. Let's say switch 3 was receiving all these 90s prefixes with the help of RIP. Fine. Now we redistributed RIP into EIGRP. Fine. Now EIGRP given those prefixes to switch 1, switch 1 given those prefixes to R3 and then to R2, and then R2 started to give in those prefixes back to switch 3. Now you could ask me that, sir, at same moment switch 3 will be giving those prefixes to R2, right? But you can configure route filtering. Let's say that we configure route filtering so that switch 3 is not giving those updates towards R2. So in that case, R2 will be receiving all those prefixes coming from R3. In that case, R2 will be giving all these updates towards back to switch 3. And now switch 3 will receive these same prefixes with the help of EIGRP. Previously, it was receiving them with the help of RIP. So it will remove all those prefixes which were learned via RIP, and will install these prefixes learning through EIGRP. Will install them in its routing table, and there will be a routing loop. So just to avoid that situation, we are having this concept of router ID in EIGRP.
It's when we were running the commands to EIGRP topology with the particular prefix. So in the external data, in the external prefix column, there was a external matric that was 0. So it is just because of that we redistribute our EIGRP into EIGRP?
I think so. I forgotten actually. I read about it. Even I taught it before in older batches, but I don't remember exactly. But yes, by default, external matric it will always show you 0. But in some cases, like if you are redistributing anything else, like like OSPF or RIP, I think it will show you that okay, this is your external matric.
We will see it when we will redistribute on R6. Then we will see it here.
No, here we cannot see them because in RIP we do not have any hop count value, because all of them are directly connected. That's the point. You can try it. Right. So I hope that you have understood the uses of router ID in EIGRP now. So if someone asks you that what is the role of router ID in EIGRP, so you will simply tell them that okay, it is just used to prevent our network from routing loops, right? So this is the only uses of EIGRP, of router ID in EIGRP, and it will be in use for external prefixes only. But in iOS 15, I will show you that it will be in use for internal prefixes too. I'll show you at that moment, right? Fine. Apart from it, let's perform redistribution onto R6 as well. So now I'm gonna move on to R6, and on R6 I have to create some of the loopbacks like 60.1.1.1, and then I have to create another loopback. I have to create how many loopbacks? 5, but I'll create only 3 because 3 are enough, right? Just to perform this practical. Router RIP version 2 node some network, and then I can simply say 60.0.0.0. You know very well that in RIP it is not possible to specify wildcard mask. That is why it's like I have to specify 60.0.0.0. I have to use a class full network in network command, because we cannot call wildcard mask. Fine. Once again, you will see that all these prefixes will get advertised into RIP. So you can look at the database of the RIP present onto this router R6. So you can look, you can run this command show IP RIP database. So you must be able to see all of them in its database table, right? But you will see that all these prefixes will not be advertised into EIGRP automatically, right? So once again, I'm gonna use route map over here. Route map, its name is Redistribute from RIP to EIGRP, right? And then I'll say permit. This is my route map, and hopefully that all of you are familiar with the route map from CCNP itself, right? However, here again I'll teach you this route map. We will implement route map, and I'll show you that how can you take different actions with the help of route map, right? So I'll be teaching all those options available in route map, but for now this is sufficient to understand only these parameters of route map. So I'll be saying match. I didn't create any ACL. If I don't match anything, then by default remember that there is match all. In route map, if you do not match anything, then by default it is match all, which means that if I do not match anything here now, if I do not specify any match command under this statement of the route map, now all the routes from RIP will get redistributed into EIGRP, and I want to redistribute actually each and every route, right, this time from RIP into EIGRP. That is why I didn't configure any ACL over here, and I'm not going to call any ACL under this statement of this route map, right? So I have configured it now, and I'll set one tag value over here. Set tag, let's say it is 60. right? And then finally I'll move into EIGRP 100. I'll say redistribute RIP, and then it is mandatory for me to specify metric now, because this time I am redistributing RIP into EIGRP, right? So in RIP by default its metric is hop count, whereas in EIGRP it is like load, bandwidth, delay, load, reliability, and MTU. So that is why here it is mandatory to specify your metric, your seed metric. Actually this is called seed metric, or you can say initial metric, right? So let's say bandwidth is 10,000, and now it will ask for delay. Let's say it is like 10, and then reliability it's like for an example 250, and then load is 1, MTU 1500, and then I can call my route map. You can take any value here in Matric during redistribution, like you could take 1 1 1 1 something like that, but of course it will affect your metric calculation. These values will affect your metric calculation, right? So this time now you must be able to see all of them into the routing table of switch 4. So let's move on to switch 4. Now you can look at the routing table of switch 4. You must be able to see all those 60s prefixes over here, right? And if you open like show IP IGRP topology 60.1.0 and then it submit mask, you can look at this output. You can see that route is external, and external metric is still 0, and administrative tag is what, 60, because I configured 60, and external routing protocol was RIP, and originating router is 150.1.6.6, which is router ID of router 6. Understood? So in this way you can perform redistribution from any routing protocol into EIGRP. And I have already taught you uses of default metric command in EIGRP, right? Default metric, like if you are redistributing multiple routing protocols into EIGRP on a single router, then with each and every command you have to you will require to specify metric, right? So to eliminate that requirement, you can define default metric onto that router, and then in future whenever you will require to redistribute any routing protocol into EIGRP, you will simply require to say that redistribute RIP, redistribute let's say redistribute OSPF, redistribute BGP, something like that. If you specify default metric, like on 2R6 you could define like router EIGRP 100 default metric like 10,000, 10, and then like 250, and then 1, and then 1500. This is the default metric, right? So now you will not require to define any type of metric over here, right? Excuse me. Fine.
इससे क्या बताया कि परफॉर्मेंस पे भी इफेक्ट आ सकता है नेटवर्क को, प्रोडक्शन नेटवर्क, तो क्या कोई सिस्को ने ऐसी रिकमेंडेशन दे रखी है कि इस टाइप के नेटवर्क के लिए हम इस तरह की नेटवर्क यूज करते हैं?
There is nothing like recommendation. It's up to you. Like for an example, if you have performed redistribution onto multiple points, right, and you wanna prefer one path, now I define these matrix accordingly. I get my point? Because if you define higher bandwidth, metric will be lower. If you define lower bandwidth, metric will be higher. Same with delay. Fine. After doing this configuration, now let's move back again onto switch 4. So we can see that prefixes are coming from RIP, prefixes are coming from EIGRP AS10. I mean, I'm just talking in perspective of external prefixes, right? So now let me perform some route filtering over here. So I'm gonna to perform that route filtering with the help of route map. So first of all, I'll teach you now route filtering with the help of route map. I'm gonna to perform route filtering now, and I'll be doing it for external prefixes first of all, and then after I'll be doing it for some other prefixes like internal prefixes. As I told you before that in EIGRP we have three types of prefixes. One is internal, external, and summary. So for internal, by default its AD value is 90, for external by default its AD value is 170, and for summary route, as we saw in previous class, it was 5. And I also taught you that why is it recommended to have AD value 5 for summary address, right? So yes, we will continue it. So let's say that I want to filter only those prefixes. I want to filter all external prefixes, actually all external prefixes, and it is quite simple to perform this task with the help of route map. So say route map, let's say its name is filter underscore external, right? And then you just need to say deny. Till now you were permitting, right? But this time I want to filter, that is why I'll say deny, right? And then the sequence number is what? 10. And then I'll say match route type is what? External. So what does it mean? That if there is any external route coming in, then this statement of this route map will filter them, right? And one more thing, if any other prefix will be received by switch 4 in this case, it will try to match with this statement external, but it's not external, so it will not match with this statement. Then it will look for another entry for this route map, right? Is there any other entry now? So it will be implicitly denied. Let me show you. If I do not create any other entry of this for this route map now, and if I apply in this form only, you see route EIGRP 100, then say distribute list route map name is filter external. In which direction? In, because for switch 4 all these prefixes are incoming prefixes, right? So this time I'll show you that this switch 4 will filter all the prefixes. You see, there is no route available actually, right? So it has proved that in route map we are also having this implicit deny rule. So now you do one thing, just come outside, say do show history, and you create another statement for the same route map, and this time say permit 10, sorry, permit higher than 10. It can be 11 as well. It's not always to, it's not mandatory to take 20 only. You can take any number, but that should be higher than 10. Why can't we take 9? Of course, like here what I'm gonna to do, I will not match anything, so by default it will be match all. So because of by default it will be match all now, so if I define its sequence number lower than 10, what will happen, that first of all prefix will come and will try to match with this statement, and here we are having match all. So all prefixes, whether it is internal or external, will match with this statement, and it will be permitted. So we cannot take its sequence number lower than 10. That is why we have to take its sequence number as 11. So now what will happen, that first of all whenever prefix will get enter onto switch 4, it will try to match that prefix with its first statement, which is having lower sequence number. So here only external prefixes will get match, and if external prefixes will get match, then action will be denied. Fine. So all external prefixes will be denied, and if any other type of prefix comes in, then it will not match with this first statement. Then it will look for another statement for this route map. Then it will find another statement for this route map itself, which is containing permit statement, and here match all. Because if you do not match anything, then by default it will pick match all statement, or it will consider match all. So by default there is match all now, and this time you must be able to see all prefixes other than external prefixes. So there is no external prefix available. Even you will not get them, you will not be able to get them into its topology table too. Show IPICRP topology, you can look at its topology table. You won't be able to get any external prefix. in its topology table too. Understood? So in this way we can perform route filtering with the help of route map, and this is not the only way to perform it. Let's say that I wanted to perform route filtering for all external prefixes, but there is one another condition. Only those external prefixes which were redistributed from EIGRP AS10 only. I do not want to I don't want to filter all those external prefixes which were redistributed from RIP into EIGRP. This time I don't want to filter all external prefixes. I just wanna filter external prefixes, but some specific external prefixes like which were redistributed from EIGRP AS10 into EIGRP AS100. Understood? So this time what can I do over here? Like you see, do show run pipe section route map. Look at the configuration of the route map. Go to first statement of this route map. Match route type was external. Fine. But along with this, we can say match source protocol EIGRP, and then it will ask for. So along with that command, that match command, now this match command will also exist there. Let me show you. Under this single statement, now I have given two match statements. One is match route type external, another is match source protocol is EIGRP 10. If any prefix was redistributed from EIGRP AS10 into 100, then it will get filtered out. And remember that it does not mean that here if any one of the condition is matching, then also it will take an action. No, if any one of the condition does not match, then your action will not be taken, because by default for route map there is AND operation and you cannot change it. You cannot modify the operation of route map. By default here AND operation works. And what does it mean? I mean, what's the meaning by AND operation? That if you are giving multiple match statements, then it is mandatory to match all the conditions at same time, right? So this time let me show you its routing table. You must be able to see all 60s prefixes but not 90s prefixes. Then now I want to modify it once again. Let's say I want to allow all those prefixes which were redistributed from EIGRP AS10 into 100, but I want to filter all those prefixes which were redistributed from RIP into EIGRP AS100. Got it? So to achieve that, actually once again what will I do? I will look at the running configuration. I will move into first statement of this route map, and then I will remove this match command, match source protocol EIGRP 10. I will remove it, and in place of it I'll specify match source protocol is what? RIP. And now you can look at the configuration of this route map now. I have modified. See, under second statement of this route map I do not have any match command. That is why by default there will be match all, right? So this time you must not be able to see any 60s prefixes available in its routing table, but definitely you must be able to see 90s prefixes. Done? Fine. Do show run pipe section router EIGRP. I'm gonna to remove it, and also I'm gonna to remove route map as well. Fine. Now once again we will see that all routes will be available in its local routing table. Done? Fine. This time I'll perform route filtering with the help of tag value. I'll be using route map. However, I'll be using route map, but in route map I'm not gonna do match like route type external route source is like rape or whatever it was, right? This time I'll be doing this route filtering with the help of tag value. As you asked me before that what will be uses of tag. So this time I'm gonna use tag to perform route filtering. We know very well that 90s prefixes are coming with tag value and 60s prefixes are coming with tag value 60. So route map name is like filter tag 60. Let's say on a filter tag 60 prefixes, right? So then I'll say deny and then with sequence number 10, and I have put deny statement over here, and then I'll match tag, and that is what? 60. So if it receives any prefix which is coming with tag value 60, that will be denied by this route map. And if any prefix is not coming with tag value 60, then it will also be implicit denied. To allow all those prefixes which are not coming with tag value 60, you have to create another statement for the same route map with permit statement, permit, and then you can allocate its sequence number as 20. So all other prefixes which will be coming with which will not come with the tag value 60 actually will match with another statement of this route map and will be permitted, right? So this time once again I'm going to apply it. Router EIGRP 100 distribute list route map name is filter tag 60. In which direction? In. Even I can also call my fast Ethernet 0x0 so that it will be applicable only for those updates which are received onto this interface of this device. So this time you must not be able to see any prefix which was coming with the tag value 60. So 90s prefixes must be available over here, but 90s prefixes must not be available. Now if you want to filter both 90s and 60s prefixes, right? Like if you want to filter all those prefixes which are coming with tag value 60 as well as 90, right? So you do one thing, just modify your route map. Do show run pipe section route map. Go to first statement along with match tag 60, say match tag 90. So this time there will be two match commands under the first statement, match tag 60 and of course match tag 90. So this time if either 60 or 90, if any one of the tag value will match, it will deny all of them. And this time it took OR operation, right? This time it haven't taken AND operation. This time it took OR operation. You know why? And as I told you before that it will never take OR operation, right? But this time you can look at the difference between commands like do show run pipe section or route map. You can look at match command. We configured same attribute actually under match command, like match tag, right? It was 60, match tag it was 90. It was not something like that match tag, match matric, match this, I mean different attributes. So if you are matching different things, then definitely it will always use AND operation. But if you have given multiple match statements but with using a common attribute, like if you are matching multiple tag values, then it will always take OR operation. Right? So this is the uses of tag value. So you can prevent routing loop, you can prevent your network from routing loops by configuring these tag values, by filtering routes with the help of their tag values. Done. So in this way you can use route maps. Apart from it, I'm gonna use this route map along with matrix as well. I mean, I can also perform route filtering with the help of metric values. So I'm gonna remove it now from EIGRP route EIGRP 100, no distribute list route map, and that was filter tag 60, and then I call interface in interface, I mean fast Ethernet 0 by 0. I have removed it, say no route map, filter tag 60. Done. I removed this configuration from routing protocol. Along with that, I removed this route map from its database. You must be able to see all of them now available in its routing table, 60s as well as 90s prefixes. Now, if I wanna perform route filtering with the help of its matric, like based on matric values. Let's say I wanna filter all those prefixes which are coming with matric, like for an example 222221056. I wanna filter only those prefixes which are coming with matric 2221056. That's very simple. Like route map, let's say filter deny 10 match matric, and then we can so if any prefix will be coming with this matric will be denied, and if any prefix is not coming with this matric, that will be implicitly denied. To allow them, create another entry for the same route map, say permit with sequence number 20. So router EIGRP 100 distribute list route map, and name is in which direction? Triple two nothing like that. Which prefix it was actually? (1056), right? It was 35 and 45. Let me show you now that is it having 35 and 45? No, there is no 35 and 45 prefix. Yes.
In this previous example, by thinking as a tag value, so it was performing an OR operation, right? So you should have filtered one tag as a value that is performing an OR operation, or
Of course, it can carry maximum one tag only.
so but it was filtering two tags.
Yes, like for an example, you perform redistribution onto multiple points, right? And you configure different tag values, and you wanna filter all those prefixes coming with those different tag values. You do not see if you will specify prefixes. I mean, if you match your prefixes with using either ACL or prefix list, you have to create multiple entries. You understand? But if you are using something like tag, like for an example, during redistribution, you allocated tag value. Now you just need to match that tag value. That's the importance of it. So on multiple points you can have multiple tag values. Like over here I used different tag value 60 onto R6, different tag value onto switch 3, that was 90. Now I wanted to fit, see let's say that I have also performed redistribution onto R4, they were coming with tag value 40. I performed redistribution onto R1 as well, they were coming with tag value 10. Now on switch 4 I just wanted to filter only those prefixes which were coming with tag value 60 and 90. So that's what we did actually. Still confused? Fine. I think we filtered with using Matric this time, right? Apart from it, let me remove it now from here, and then let me remove this route map as well. No route map, filter And apart from it, now we can also do one thing. Let's say that I'm on R5. R5 is receiving some prefixes on serial 0 by 0, on serial 0 by 1, on serial 0 by 2, on fast Ethernet 0 by 0. You can look at this output. Some prefixes are coming on serial 0 by 0, some on serial 0 by 1, serial 0 by 2, and definitely on fast Ethernet 0 by 0 as well. Now, your task is something like this. For an example, if you want to filter all those prefixes which are received on its S0 by 0 and S0 by 2. You want to filter only those prefixes which are received on S0 by 0 and S0 by 2. You can do that with the help of route map. Like you do one thing, route map. Its name is like filter, deny. Sequence number 10. Match interface serial 0 by 0. Match interface serial 0 by. To allow all others, same route map with permit statement, higher sequence number 20. That's it. Now you can look at this route map, do show run pipe section route map. Again it will take OR option. OR operation. So router EIGRP 100 distribute list route map name is filter. I'm not going to apply it on any interface because here we are filtering onto multiple interfaces, so we have to apply it globally in its inbound direction. So this time you can look at its routing table. It must not receive anything onto S0 by 0 or S0 by 2. See, all the prefixes are learned onto S0 by 1 or fast Ethernet 0 by 0. Done. Now router EIGRP 100, once again I'm gonna to remove it from here and I'll say no route map and its name was filter. That's fine. And then once again all the prefixes are available on different interfaces like serial 0 by 0, serial 0 by 2, everywhere. You can also define like range of Matric as well. I think you performed it during CCNP itself. Like you can define Matric range, like if prefixes are coming with Matric in between, like for an example, you wanna perform route filtering for all those prefixes which are coming with Matric from 100 to 200. You just wanna filter only those prefixes which are having Matric in between 100 to 200. So you can also achieve it with the help of route map. Like you can define here range like match Matric under route map statement, right? Like match Matric and 150 plus minus 50. Because if I take 150 plus minus 50, which means this range would be there. Plus minus means if you subtract 50 out from 150, then it would be 100. And if you add 50 into 100, so 150 into 150 actually, then again it will be 200. So this range will be defined in this manner. So if someone asks you that, for an example, if someone said that, okay, you have to filter all those prefixes which are coming with Matric in between 100 to 200. First of all, you will calculate the difference in their matrix. So it is what? 100. You will divide it by 2. It will become 50. Now do one thing. Add this calculated value in your lowest given Matric. That will become 150. And now add and subtract this output itself in this output. 150 plus minus 50. I mean, finally you have to define your range, right? In terms of plus minus. So that's possible actually in route map. You can do it like on to stage 4 itself. If you want to configure route map, filter, deny, match matric 150 and then plus minus, then you can take 50. That's the meaning. I mean, in this way you can configure this command. Hopefully you can do it by yourself now. I mean, you can perform all these practicals of EIGRP by yourself related to route map. What?
AD
You can do that, but in route map you cannot define your AD value. But in previous class I told you that how can you perform route filtering with the help of AD value. Right? See, in route map actually you have match command. You can match your route in this manner, right? So in here actually most of the attributes or most of the options will be used in BGP only. Similarly, set, most of the set commands will be used in BGP only, not in EIGRP. In EIGRP we are having very few options that can be used. Any problem? Fine. Route map is done. In route map, it is not always necessary to match your prefixes with the help of matric, interface, or tag, or like route type. It's not like that. You can also match your prefixes with using either standard ACL or prefix list too. To match your prefixes in route map, you can use either ACL or prefix list. So if you want to use prefix list, I'll let you know that how can you use that. Show IP route. Let me show you that this time all the prefixes must be available over here. That's fine. So let's say I want to filter all those prefixes which are having odd number in their third octet. Odd number in their third octet. I want to filter all those prefixes, right, with the help of route map itself, or you can achieve it with the help of standard ACL too. So first of all, I'll do it with the help of an ACL, because you can also perform route filtering here in EIGRP with the help of standard ACL, extended ACL, with the help of prefix list. Because in EIGRP, when you configure distribute list, you will find all those options, right? You will get all those options available here, like distribute list, and then you can call either standard ACL, extended ACL, or prefix list, or gateway keyword is also there. And I'm not gonna to perform all these practicals now once again, because I already performed them during RIP. In RIP, I told you that how can you use standard ACL, how can you perform filtering for like even numbers, odd numbers, right? Then I configured extended ACL, right? So here in EIGRP2, you can configure route filtering with the help of extended ACL. Understood? Apart from that, you can also use prefix list here. And prefix list, I mean the uses of prefix list is same as that we used in RIP. And I told you differences in between prefix list and ACL. That will remain same in EIGRP as well. So here it is not required for me to go for all these practicals, because you should be aware now to perform all these things, right? Because we have already learned about all these things during RIP. Even command syntax is completely same as RIP. There is no single difference in its command. Once you just need to move into router mode, and then after syntax is same as RIP. So standard ACL, with using standard ACL you can perform route filtering, but you cannot specify that, okay, you cannot specify your source, right? But if you wanna perform route filtering, you wanna perform source based route filtering. Like if I'm receiving these prefixes from these sources, then they should be allowed, and if we are receiving these same prefixes from any different source, then all these prefixes must get filtered out. So for that purpose we can use here extended ACL. Because in extended ACL you can call source as well as prefixes. Fine. Now tell me, should I go for this or you will be doing it by yourself? Distribute list with using standard ACL, extended or and prefix list. You do it by yourself, right? This is your homework. I'm gonna to use these things within the route map, right? So as I told you that I wanna just filter all those prefixes which are containing odd number in their third octet, right? In any prefix. So I'll be saying that access list 10 permit. This time I'm not gonna to say deny in ACL, right? However, I wanna deny all these prefixes, but in ACL I'm not gonna to deny. Remember that if you are calling either access list or prefix list in your route map, and in access list if you specify deny keyword, then those things will not be matched. Remember, if you wanna match anything with the help of either ACL, whether it is standard or extended or it is prefix list, if you wanna match anything with using ACL, you have to say permit. You have to use permit keyword to match anything. And this time I'm not gonna to use ACL to take an action. I'll be taking an action with the help of route map. So I wanna use an ACL just for matching prefixes, right? So I'll be saying access list 10 permit, and then I'll say 0.0.1.0. Then I'll say 255.255.254.245. It's not it. It will match only those prefixes which are containing odd number in their third octet. सर आप एब्सेंट थे, मैं क्या कर सकता हूँ इसमें? अब तो हंसोगे ही, फिर नहीं आएगा समझ में. Right? Then route map. I wanna filter all these prefixes, right? So I'll be using like route map. Its name is CCIE. I'll be saying deny. Sequence number 10 match IP address. Right? So whoever will match with this statement of this ACL will be denied by this route map. And now you know very well that all the prefixes are not gonna to match with this statement of this ACL, right? So what about all those prefixes which will not match with this statement of this ACL? They will be implicitly denied. To allow all of them, I'll be saying now route map CCIE. I'll be saying permit with higher sequence number 20, and by default they will be match all. So all those prefixes which will not match with the first statement of this route map, because over there I use this ACL, all those prefixes will match with another statement of the same route map, and all those prefixes will be permitted. So this time I'm going to apply it now. Router EIGRP 100, then I'll say distribute list, and route map name is CCIE in which direction? In. And now you will see effect of this command on the switch 4 itself. Let it resync first. Yes, it has resynced. Now you can look at its routing table. You see, it's containing only those prefixes which are having even numbers in their third octet. Then
सर वो ACL में IP एड्रेस कैसे लिखते हैं?
कहाँ लिखा? ये था. हाँ, रिप में समझाया था ना?
सर एब्सेंट.
हाँ तो रहो एब्सेंट. क्या सर? एक्सेस लिस्ट 20 permit 0.0.1 0.0 255 With this statement, all those prefixes will match which are having even number in their third octave. क्या क्या सर
थर्ड ऑक्टेट थर्ड ऑक्टेट जीरो सर
अरे कोई भी इवन नंबर ले लो यहाँ पे 0 ले लो 2 ले लो 4 ले लो 100 ले लो 254 ले लो तभी कहता हूँ मैं ईच एंड एवरी क्लास इज इम्पोर्टेंट. अब आज जो नहीं आए होंगे वो राउट मैप में प्रॉब्लम आएगी उनको. अब नेक्स्ट में तो मैं यही कर रहा हूँ ना, सेट और मैच.
ऑड में भी सिर्फ .1 की जगह .35 कुछ भी ले सकते
कुछ
हैं.
भी सर. You can use prefix list for the purpose of route filtering here. I'm on 64 and then I wanna, let's say after EIGRP 100 distribute list, just remove it, say no route map, that is CCIE. Fine, and that's okay. Try the route. All of the routes must be available in its local routing table now. With using prefix list is same as RIP, completely same as RIP. Let's say I want to filter all these 90s prefixes only. So I will say IP prefix list CCIE deny 90.1.0.0/21. All of them will be covered in it, and then I can say greater than equal to 24, less than equal to 24. Then I'll say prefix list CCIE permit 0.0.0/0 less than equal to 32. And then under router EIGRP 100 I can say distribute list, prefix list, name is CCIE in which direction, because all these prefixes are incoming prefixes, inbound prefixes. It's very simple. It's completely same as RIP. And here I'm not gonna to give you that example that we took during RIP. Do you remember? /25, 26, 27, 28, 29, /30. So I'm not gonna to do that now. So IP route, so all 90s prefixes will be flushed from its routing table. Right? So in this way you can perform route filtering in EIGRP. Hope you understood it. Right? Excuse me.